Let's get going. Before I do, thank you for the gracious introduction there, Daniel. But this is me, Justin Schroeder, as he said. You can follow me on X. And if you've ever heard of me or not, it's probably because I've written some open source package that floated across your timeline. These are sort of little labors of love and passion projects. Some of them are more used than others. Some of these have thousands of stars, tens of thousands of stars, and my poor little Zodown has like 10. I don't know. I don't know. Anyway, these are my open source contributions, but that's not what I'm here to talk to you about. I'm talking about MCP, and everybody's talking about MCP, right? It seems like it is, by far one of the most common things that you're coming across right now. And based on this, smattering of YouTube thumbnails, you would think that MCP is the savior that we all must worship in the future. And I'm here to give a more balanced view of MCP and tell you where you might want to use it and where you might not. But one of the big questions that I see people having is, what is MCP actually? And I don't mean like, how do I use it? Because everybody's sort of already using it. Surely you at this point have installed MCP into Claude Code, some MCP server, maybe Playwright or something like that, or maybe you've dabbled with it in ChatGPT. It is being used for sure. But even us developers who are using it in our own dev pipelines often don't really understand what it is and what it isn't. So I'm going to take some time and actually walk through that with you. So this is from the MCP spec itself. MCP, Model Context Protocol, is an open source standard for connecting AI applications to external systems. Simple enough. I think we can understand what that's trying to do. Now, people still try to make an analogy for it. And, here's one, how MCP servers work. Let me demolish your confusion. And we've got this MacBook here and a USB hub. And the USB hub is MCP. And then all these things that plug into it are MCP servers, which I actually think makes it even more confusing than what it really is. But I definitely know it's not USB. So that's not a good analogy. Let's ask ChatGPT, what's a good analogy for MCP? MCP is like a USB for AI tools. Okay, well, that's not helpful. That's the same thing. One universal port and one protocol. Okay, interesting. How about the MCP docks themselves? Think of MCP like a USB-C port for AI applications. I find this so unhelpful. So let me just throw away the analogies because they're about as helpful as saying that a potato is like a girl, because there was one time a toy potato that you could plug eyes into. It's not a helpful analogy at all. So let me actually walk through the process of MCP and why we even need it in the first place. Let's imagine that you're chatting with Claude, just on their website or ChatGPT or something. And you say something innocuous like, hey, check my email, please. Well, obviously the AI is going to respond, I don't know how to do that. It's kind of an obvious response. Obviously, it doesn't know how to do that. Now, what's a little less obvious is that above all of this conversation, there is a system message. If you spend any time working with these AIs via the API, you're familiar with the system message. It basically tells the AI who it is in the universe. So it might say something like, you are a helpful assistant. Answer the user the best you can. If I want that email to get checked, though, something else needs to happen. And that's where we get to tools. Tools are like functions. So here's a definition for my check email. It basically has the name of the function, a description of when I would want to use it, and then the information that's required to call the function, the number of emails to go get, for example. Now, how does my AI know that it can call that tool? Well, it goes back to that system message, the you are a helpful assistant. Basically, the actual system message, when you have a tool, looks like this. This is directly from the Claude API documentation. In this environment, you have access to a set of tools. You can use this to answer the user's question. String and scalar parameters should be specified as is, blah, 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 blah. And then the important part is, here are the functions available in JSON schema format. And that's where our tool makes it in. This is actually all of the magic of tool calling. It's just injecting these definitions into a system prompt. There is no like grand procedural hierarchy of the way these things work. AIs don't actually know how to call tools at all. They've just been trained to spit back JSON fairly effectively in some cases. But the way that it knows how to do that is literally the system prompt. So the question is just, how do we manipulate it? Now, when you go to chat, you say, check my email, please. It goes and reads that and will spit back some JSON for you. But how do I get my system or my definition into that system prompt? And even more importantly, MCP wants to know, how does Starbucks get their tool into your system prompt? That's really the question that they want to solve. How can I be on ChatGPT and order something from Amazon? This is the fundamental MCP question. And you do that, of course, by injecting additional tools that MCP wants to help you do. So let's break this down into an actual real life example of how this would work. In MCP, you have different pieces and parts. There's always the LLM provider. You could think of them sort of like the LLM API provider. Then you have the client, and the best example of this is probably something like Cursor or Claude Code. ChatGPT also falls into this category, but basically it's code. There's no AI magic in this part of the stack. The client is just code that receives messages and sends it out to other places. Then you have your MCP servers. We'll learn more about those, but these are the third-party things that you want to use. And then those have access to a machine somewhere. It could be their own machine, it could be an external machine, but somewhere where the functions will actually get called and do something. So now I type in, check my email, please. When I hit enter, it's going to send that to the client, right? And then the client sends that to the LLM provider. But in order to do that, it first needs to create a prompt. Now, this prompt is assembled by that client. And the client says, actually, I have some MCP servers attached to me. So before I send this prompt, let me run over to them and see if they have any functions to include. And sure enough, my MCP server for Starbucks or my Microsoft account, they say, yes, I have a tool to expose. And those get attached via the client to the prompt. So now my prompt has that system message with their definitions in it. This gets sent over to Claude, which is my LLM provider in this case. And Claude does AI magic to decide, I'm going to call this function. And then it takes that function and sends it back to the client, right? That little tool call, it sends it back to the client. The client then remembers, oh yeah, I remember this function. I got it from that server. So it sends it off, in this case, over to our Microsoft MCP server. It says, oh, I need to go fetch some account information. Let me go do that. It performs the actual function. Now the result comes in. Hey, no new messages. Okay, that gets sent back to the MCP server, which then gets sent back to the client. And now it needs to get sent all the way over to the LLM provider. Well, in order to do that, we need a prompt. So a prompt is created and our new status is attached. But then this is a client with MCP servers. So we might need to attach some functions. So we go back to our MCP servers to get the functions. What functions are available to me? Oh, okay, there's some new functions. So now we take those and we attach those to the prompt. Now, if they were cached, maybe you could not have to actually go communicate with the server. Just depends. And then we're going to take this bundle of joy and we're going to send it over to Claude. And Claude's going to read through all of that and decide, I'm not going to call any of these functions. I'm just going to respond to the user, no new messages. It responds back to the agent, to the client. And then the client responds back to you. That is MCP. That is how it works. It's not a mystery. It's not efficient, but it's not a mystery, but that's how it works. Now, the reality, though, is unfortunately not quite that pure, because those MCP servers don't just have one or two tools. No. These MCP servers are littered with tools. They have so many tools. They are absolutely overflowing with them. So if you install even a couple, like the number of little, red Fs that I just put on the screen there is less than the number of actual tools that will get in your system message if you install a couple of these servers. Let's take a look at Playwright. So the Playwright MCP has no less than 31, as of my last counting, tools, and they all get sent every single time. There is a way to manually go through and disable these, but nobody does that. They all get sent on every single request to the LLM. So let's just look at one of these, browser drag mouse. Okay, what does the definition for that look like? Well, it looks like this. You can see browser drag mouse. It's got the description, just like we talked about, and then it's got some properties. It needs to know what element's going to be dragged and where it's going to be dragged to, and so on and so forth. It's not particularly complicated. It's just one of them. How does an AI see this, though? So we could take this and put it through a tokenizer, and it would look like this. Here you can see each of the tokens involved in this LLM request. JSON is not particularly efficient with tokens. If you look even on the left-hand side over there, you can see there's like little blocks of white space. Even those white spaces are new tokens that need to be sent along. There's other formats that you guys have probably seen floating around on Twitter, like token object notation, which is interesting. But the matter of the fact is that in all right here in this one tool are 234 tokens. So let's just assume all the other ones are the same. That would be 7,254 tokens on every single request that you send to the LLM, just to let it know what tools are available if you have this one MCP server installed. That does definitely increase and inflate your token costs, which is something that you can kind of deal with, and over time, hopefully our token windows get bigger and bigger and bigger. But there is one thing that hasn't changed a whole lot yet, and that is the fact that the tool selection is worse the more tools you have. In fact, it's highly correlated. Some models are different than others, but a lot of models start suffering with the selection of the correct tool with as few as 10 tools. It's pretty wild. And it's not like it's going to choose the wrong one every time. It's just statistically going to start choosing them at a higher and higher and higher rate the more tools you have. Also, the larger your context window, you probably have seen this in your own coding, the dumber your agent gets, the dumber the LLM gets. It starts to lose attention and lose focus. And so inflating every single request with a whole ton of tokens is challenging. I think at some point in the future, maybe there'll be some sort of progressive discovery of the tools that are available. But as of right now, that's not the case. And this chart right here, which is highly scientific, as you can see, it's a line going down and to the right, is the main problem. So yeah, I think this is the point where I should just come out and tell you, if you haven't noticed already, I don't like MCP. I don't like it. I don't like the spec. I don't like the way they went about solving the problems. I think it's very well intentioned, and I think it solves a real need in the ecosystem, which is why you're going to continue to see it. But I want to tell you a little bit more about why I don't like it, so you cannot like it with me and just use the good parts. Let's talk about that specification. Here are the design goals. So I'm going to just slowly walk through the spec here. All right, design goal number 1, servers should be extremely easy to build. Totally agree. Servers should be highly composable. Totally agree. Servers should not be able to read the whole conversation nor see into other servers. This is interesting. I'm going to make a bold guess that this will slowly evaporate from the MCP spec over time. And number 4, features can be added to servers and clients progressively. I actually think all of these goals are quite good. Number 3 has some downsides, but overall, I would say this is quite good. So this is not where the problem is. Now, how do we actually communicate? So remember, we've got the server and the client that need to talk to each other. Well, they happen through these messages, and these are dead simple. They're JSON RPC, which means they're intended to be calling something on the other side. So here we have a request that calls a method with some parameters, some arguments. And then the response comes back with the result or the error. Unbelievably simple. Now, there is also in the MCP spec another message type, which is exactly like the other ones. It's just missing the ID. And then you're supposed to treat this magically as a notification. So in this case, you might be saying, your server might be saying to the client, hey, I have some new tools, you need to go refresh. That's called a notification. But those are the message types. Then the spec defines the players. You've got the human, you've got the client, and you've got the server. The spec generally talks about the human more like the host and the host machine that this is all running on. That's okay. We're going to just say it pans out like this. So human, client, server. Then the spec defines a life cycle. Now, this is interesting if you're coming from a web background because we don't really think about life cycles that much, but this API has one. So when you initially connect as a client to an MCP server, you basically need to negotiate about the features that are supported. This is one of my gripes about MCP is there's so many features in MCP that so few people implement. They need a lot of this extra hand-holding in order to decide what they're both going to support. It's not that big of a deal, though. It's just a tiny little JSON that basically says, I have some capabilities as the server, and then the client says, oh, I have some capabilities as a client, and you kind of agree on what they're going to be. So this looks like a couple requests that happen beforehand. Then you go into the operational phase, and then you eventually shut down and you disconnect. A little unnecessary, but whatever. So here are the capabilities of MCP. And the one that we've already talked about is tools, but what the heck are all these other things? Let's look at them. So here are a bunch of other capabilities. There's this routes capability. This is the ability to provide file system routes. So basically the ability for the client to say, I'm running here in the user's file system. Interesting. Then there is sampling. Sampling, the spec defines it as essentially the client saying to the server, hey, I know you don't have access to an LLM. So if at any time you want me to run a request with the LLM that I'm connected to, I can go ahead and just do that for you. So the server can send the client a request that has nothing to do with a tool call or anything like that. And it'll just go like run it on the LLM and then send the result and pass it back to the client, pass it back to the server. Sampling. Elicitation is when the server tells the client to ask the user a question. So, you're in Claude Code, you start editing some file, Claude starts editing some file, and the server is like, I don't know if I should be doing this. Let me ask the user to get human input. That's what elicitation is. Then there is experimental. Okay. Then there are prompts. So your server can define prompts that the client can choose to implement. The server is defining the prompts. Interesting. Then there are resources. These are basically like prompts, but think of them more like files. These are files that the server is saying, hey, I have access to these files. And client, if you ever want to use them or manipulate them or send them off to the LLM, I have them available for you. Then there are tools. Aha, this is the thing everybody loves, is the tools. And logging. This is interesting. The server can tell the client, I can log things for you. So then the client can say, oh, hey, when I get an error from the LLM, I'll go ahead and send that along to the server, and the server will do logging for me. This is one of the pieces of the spec. Then there are completions. Completions are also part of the spec. This is basically like in an agent like Cursor Claude Code, when you hit the @ symbol and it shows you all the files and you can choose one. Well, the agent, your client, could be doing that work, or you could ask the MCP server, hey, what completions do you have for me? I could actually see this possibly being useful if you are connected to some remote MCP server, like let's say a Google Docs server or something like that, and you want to be able to reference other files with some sort of @ symbol in the client. That could be moderately useful. And then we have experimental. This is the server now experimental. So you got the experimental on the client, you got the experimental on the server. Everybody can be experimental. You can do whatever you want with MCP. So those are the capabilities. Now, another critically important part of the spec is this idea of transports. Transports are how the JSON RPC messages are going to make it from the client over to the server. How are they going to actually send the message? And the spec has 3 of these for us to examine. One is standard IO. So if you are installing an MCP server on Claude Code, for example, there's a really good chance you're interacting with it. Well, Claude Code is interacting with it via standard IO. So you could think of this sort of like just a command line utility that is the server. Another option would be a streamable HTTP. So if you have tried out using ChatGPT or something like that to talk to an MCP server, there is a 100% chance that the way you are doing that is through the streamable HTTP. In my opinion, this is the only one they should have put in the spec. That's just me. Their third one that's available is whatever the hell the next guy decides to do. No, for real, there's a sort of whatever you want transport. It's not defined. It's just like if you want to write your own transport, that's cool. As long as the MCP server and the client both agree on it, then I don't know why we're even part of this discussion. That's basically what the spec says. Now, a really interesting thing about standard IO is that it's inherently stateful, right? Like imagine, you're using some web server to do development locally. You start it up, right? And you're starting to send HTTP requests, and in your CLI, you're seeing all of the HTTP requests come in. Well, that's stateful. We know one to the next on there. So the standard output for that is inherently stateful. But that's a little more questionable with HTTP because HTTP it can be stateful, right? We can send sessions back and forth with it. But what we've sort of learned over time is that statefulness in HTTP is kind of a bad idea. Often it causes lots of problems. There's little pieces of time where you kind of need it, but overall we've decided, hey, like let's not have a stateful API. Like if you're going to ask for a page and then you ask for a page again, it should be the same page, not the next page. If you want to ask for the next page, you should pass a query parameter to get the next page. You guys are all familiar with this concept, I'm sure. But in the case of MCP, the streamable HTTP is actually recommended-ish to be stateful. Let's look at the spec here. It says a server using the streamable HTTP transport may assign a session ID at initialization time by including an MCP session ID header on the HTTP response containing the initialized results. And then it defines, what that should look like. So very interesting that it can be stateful. This other category, I don't know, do whatever you want, I guess. So this is probably my biggest problem with MCP. It's basically like trying to take the road and have every form of transportation run on it. And it causes the spec to get really big over time. It needs to handle almost everything. In fact, if we go all the way back to this list of things, the capabilities that are available, I think you'll notice something. Remember that MCP was created by Anthropic. They kind of just released it out of the blue. And if you read through here, provide routes, elicitation, prompts, these are basically the features of Claude Code. A prompt is basically a / command. Resources are sort of like the files in your file system. The routes are what's there. All of these features are enabled by MCP. You could basically build Claude Code as MCP. So it's almost less of a context protocol and almost more of an agent protocol. Okay, let me jump back forward here. So I think we're trying to get too many things to run on the same road is kind of my point here. So if it's so flawed, then why is MCP such a big deal? Because it is a big deal, right? Why is it such a big deal? Come up with an answer in your mind. It's tools. That's why. The reason MCP is successful and implemented in so many places is because it tells us how to get those tools in the context. That's what we all want. And as long as MCP is providing tools, it was the first to the market, it was the first to party, it's going to stay around, I think, for a long time. We're going to have MCP as a tool delivery mechanism for a long time. And yeah, you know what? So what? I don't like all the other stuff in the spec. This part of it's not bad, other than it doesn't have progressive discovery and, like all the statefulness and all that. But if you look at it as just a tool delivery mechanism, we can live with that. And in fact, I think everybody's living with it. Take a look at this. This is right from the MCP docs. These are MCP clients and what features of MCP they implement. And there's a lot of them. And you'll notice they don't implement very many, except that tools column is solid green all the way down. This is what people want. More than anything else, this is what people want. So how is MCP going to actually affect the world? Allowing non-engineers to talk to the code base is an underappreciated use case for coding agents. I agree. The new front end will be UI snippets that will be returned from MCP servers to be rendered in your personal agent. Agents will control the experience and will display only the specific visualization or interactivity piece that you need from every app. I agree. MCPs really are the future. Non-technical users don't want to run and install command line tools. Of course, undoubtedly. And Kent is really onto something here. I think the future of MCP is much less about your coding agent and using them in your coding agent, although they do have some really interesting use cases there. And it's much, much more about this. It's about creating the next generation of interface for anything, your coding agent, your admin dashboard. As developers, I think we spend a massive amount of our time building out the admin tools for our own teams to use internally. MCP can almost replace that entirely. So we're actually starting to see this already, right? ChatGPT recently announced this idea of apps, which is basically just taking MCPs and allowing them to do a little bit more, like return some UI kind of stuff. And I think we're going to see more of this. So let's build an MCP server. How are we going to go and actually do that? I want to actually build an MCP server so you know that you can do it, and I know that you can do it. We're all going to be happy here. Well, the way to do that is to start with the MCP SDKs. And it turns out that Anthropic and the Model Context Protocol organization have already launched a lot of these. There's one for Swift, there's one for Rust, there's one for Ruby, one for PHP, one for Go, one for C#, one for Kotlin, one for Java, one for Python, and of course, one for TypeScript. But you know what's funny? These are not well maintained. They are trying to run on a single node server. They're not particularly good for serverless. There's all kinds of interesting problems with them. And at the end of the day, you don't learn how to build a server. So I'm not even going to use this thing. We're going to build a server from scratch, right? This talk is MCP from scratch. So let's build it from scratch. All right. Transports. So we're going to use the streamable HTTP transport because, of course, it's the only one. And as a streamable HTTP transport, obviously it's going to use REST, right? No. You remember this funny tweet that was going around recently Pro tip, REST is over engineering. Just expose one endpoint called /API that accepts SQL queries directly. That was a funny one. Obviously, it was a joke. It's not a joke in MCP. That's how MCP works. The server must provide a single HTTP endpoint path, hereafter referred to as the MCP endpoint, that supports both post and get methods. For example, this could be a URL like https://example.com/MCP. Okay, so we need to go implement that now. But showing is better than telling. So I am going to leave this and be highly risky here. And we're going to try to actually run code and look at code. Obviously, I'm not going to write all of this by hand. Whoa. I'm not going to write all of this by hand in this exact moment. I've done a little bit of pre-work here. You can see 11 hours ago I was working on this. But let's take a look. So basic stack here is I am using Cloudflare's worker SDK via Vite. They have a Cloudflare Vite plugin, which lets you use Vite to set up a Cloudflare worker. It's spectacular. I highly recommend it. But the reason I wanted to do this is to show you that this can run in totally non-server environments. Cloudflare is not even just like a Lambda. It doesn't even have access to like a full node. It uses basically a layer on top of a node server. And the way that they do that is they give you a single function that gets called with any HTTP request called fetch. So here we have our request, and then we just need to respond to it somehow. So let's read through what's happening here. We've got some CORS headers, and then basically we just have we have a little landing page. We just have a whole bunch of auth endpoints. Now, the MCP server that I'm going to be showing you is for X, for formerly Twitter X. I actually last night, I got invited, as I was about to sit down and do this, I got invited to the new API. If you guys are familiar with X, they've ruffled a lot of feathers. A couple years ago when Elon bought it, he like jacked up the prices on all the API and got really expensive. Well, they're now coming out with a closed early access of a new pricing model, which is basically a pay-per-request kind of model that's much more affordable. And I got into that and I thought, wow, it'd be cool if I built an MCP server for X. So that's what we're seeing here. So here is our OAuth flow. The whole OAuth flow to log in to X is all in here. But really, none of this stuff is MCP. We don't care about it. It's just like how we're going to get in. Here is what we care about. This is our MCP endpoint /MCP. Okay? And if we go now and we take a look inside of handlers, MCP, this is the code that actually runs the MCP. And I want to show you how gosh darn simple this thing is. So here is my request body. It's coming in. We just make sure that it is JSON RPC 2.0, because if it's not, then we can't talk to it. Then the next thing we do is we check to see if the method that's being passed is initialized. Remember how we talked about it has that initialization step. Well, if it does, then we need to handle that. This is not complicated. We are basically just going to spit back the capabilities that we have, which in our case are some tools. Okay? We're going to spit that back. So that's initialize. Then we need to respond to the notifications initialized. This is how we all say, okay, we're all done. We're all initialized. Then a lot of the MCP clients have this concept of pinging an MCP server just to make sure, like, hey, everything okay over there? So we're doing that too. Then we have the ability to list tools. Then we have the ability to call tools. And that is it. Now, this is my MCP server. So you notice that I am not implementing any of those other features that we talked about. And I'm not implementing statefulness. This is completely stateless. Yes, there's an authentication layer, but that's a different thing than statefulness. Statefulness would be like I'm holding on to some memory values from request A to request B. We're not doing that. We are just exposing the tools and letting you call the tools. And if you're authenticated, great. So let's take a look at handle tool call, because this is kind of one of the important things. basically we get the values in and a name and some arguments, and then we go get the tool by the name. If it's not there, we throw an error, and then we actually run the tool. We have a Zod schema for each of the tools, and we execute the tool. We take the result and we throw it back to the user. This is genuinely not complicated. It really isn't. I know that we're not digging into the details of this, but just promise me when I tell you it's not that complicated. So what are these tools? Like it says here, load tools. Well, I have a tools directory. This is just the way I decided to set this up. This is not an SDK. You can set this up however you want to set it up. Or you could use the predefined SDK. So let's take a look here. I've defined these tools right here. So like get account details. Here's my tool. I wrote a little utility called define tool. And that way I have some nice TypeScript types here. You know, it's expecting a name property. And this is the name of my tool, get X account details. And here's a description, get the authenticated user's X Twitter account details and profile information. It expects a particular schema. And then there is this in the spec, it defines, like they're not even part of the spec really, but it sort of talks about these things called hints, and everybody's sort of glomming onto this. So like if you want to say that this tool is a read only, you can say I have an annotation, it's a read only hint. And then when you load that up in an agent like ChatGPT or something, it's going to automatically have that sort of sorted out for you, that that's a read-only tool versus a write tool, and it'll have different behaviors based on that. And then we just have a function to execute the tool. Now in this case, the context that's coming in already has the authenticated user, and we've stored that information on our side, so we're just going to spit this out without ever even talking to the X API. Now that is not true on this tool here, get followers. Get followers implements the XAI API. So here you can see that now on this tool, we're actually making a request to the X API, and we are using, you know, our X auth tokens and all of that junk to make that work. But generally, this is like you as a developer are already familiar with consuming an API. We're just consuming that API in a function and then telling the MCP server that that function exists. I mean, that is like actually how this works. It's not more complicated than that. And if you keep MCP simple on that level, it stays simple. Okay, so it would be nice if we could see if this actually works. Like, how do you see if an MCP server works? Well, one of the great things, truly great things that the MCP protocol did early on is they released an inspector. So in my package JSON here, you can see I have this inspector command, npx model context protocol / inspector. I'm going to run that npx command. So I will do that. I will just, pnpm run inspector. And this guy is going to go ahead and boot up, and it runs its own little server. It's spectacular. Okay, here's my little server. And what is this? Asking you. Yes. Okay. And then over here, I need to move you a little bit out of the way. Okay. Over here, I'm going to start up my server. So I'm going to boot up a dev server. Now this is my Cloudflare server running locally, and it's booted up here at 6543. And this is my server. So here is my little MCP server. This is that landing page that we talked about. And this will go and do a full OAuth flow with X. Now, this piece of it is just old school programming. Nothing here is magic AI. So I'm going to go ahead and authorize. And now my MCP server created these JWT tokens for me. You can use basically whatever authentication you want. MCP has some suggestions about it, but whatever. I'm using JWT, so I'm going to copy this auth token. And now I'm going to go over to the inspector. So the inspector booted up over here. I'm going to go to it. And here you can see that is the endpoint on my local host that I need to connect to. So I'm going to go to authentication, and I'm going to just make sure I put in the token I just got. Bearer token, whoops, And there it is. And now I'm going to come down here and click connect. And you can see we successfully connected to our local MCP server. And here, remember, we established what are the capabilities. And the capability we said we had is you can list tools. So we can click this button and we can see our tools. And sure enough, there they pop up. Here's our get X account details and our get followers. So I can now click on this tool or this one, and I can see, hey, those are the arguments over here that are required to run those tools. So that is essentially what ends up in the system message of the LLM when it gets sent off to, Anthropic. So this one doesn't require any. I can go ahead and run the tool from the inspector, and sure enough, I get a value back. And how about this one? So let's see here. I run this tool, my user ID, I grab that. Let me just paste that in here, and I'm going to get followers. This is going to get, I don't want to get a lot of followers. Let's get 10. All right, so this is going to get 10 of my X account followers, people that follow me on X. Pretty cool. So that is how we actually set up and run an MCP server. But we're not done yet. Let's go ahead and actually connect this to ChatGPT. So here we are in ChatGPT. And if you didn't know this, ChatGPT, as of, I don't know, a month ago, really recently, they started supporting MCP connections. So if you click on this little plus here, you can go down and you can say add sources. And then you can click this little add button. And then you can go down and click connect more. OpenAI is doing a great job on a lot of things. Some of their UI could use a little work. Call me. Okay, now we scroll down to the bottom of this window and we can go to advanced settings. And then we can turn on developer mode. The reason this is hidden behind so many different flags is that MCP servers are inherently dangerous. You've probably heard Daniel Kelly say that the S in MCP stands for security, and that's 100% true. I am literally giving an AI that's open to cross-pollination and injection and all kinds of other stuff the ability to call tools on my system. Something to think about. All right, I'm going to go back here. And now I get this little magic button that shows up. I can click that. And now I can create my own custom tool on here. So I'm going to say this is my X MCP. Makes requests to the user's X account. All right, so MCP server URL. Where do I get that? Well, I'm going to go ahead. I'm going to shut down my inspector. We don't need this anymore. And I'm going to just deploy this. So one of the lovely things about Cloudflare is their deployments are really fast. So it's pushing this up onto the web, and it's going to give me a URL. Here we go. Here's my URL on the interwebs right there. And I'm going to put that in there. And then here you can see authentication. Okay, OAuth. Yep, I'm going to do an OAuth flow. And that's it. Now, what's really cool about this is my MCP server is going to do the authentication automatically through X. So when I say create on here and it starts doing all the fancy negotiation, it actually takes me to X to do the login. I'm going to say, yes, I authorize this app. It's going to bring me back to ChatGPT. You can do it. I believe in you. Come on, baby. Come on. Come on. Oh, something went on setting up the connection. Let's try this again here. Oh, okay. Connect. Authorize app. I believe in you. I don't know. It's unhappy. Let me try making sure all the migrations have run. Yeah, it's all good. This actually might be on OpenAI because we've been connecting perfectly fine. Okay, well, that's depressing. Let's see if we can get any of the actions. That doesn't look promising. Okay, here's what I'm going to do. I am going to check out my main branch. And the only difference between that demo one and the main branch is the amount of tools. Here you can see I have fleshed out all of these other tools, which is basically like all of the read-only API that's available from X. I'm going to go ahead and deploy this one. Maybe it was just a bad deploy or something. Okay. And I'm going to also make sure that all my remote migrations have run. I'm sure they probably have. Great. So if I go here, let's see. Okay, let me log out here, try logging in again. Huh, okay, so my server is working fine. Let's see if we can get OpenAI's server to work. Delete it. And I'm just going to do a hard reload on you, buddy. And we'll create another one, XMCP. And we will put in, oh, you know what I did? I wonder if I didn't do the /MCP on the last one. I don't remember doing that. Got it. Let's create this. I bet you that's the problem. All right, log me in, buddy. Hey, XMCP is now connected. Sorry about that little detour. And here's what's cool. We can see all of the tools that we defined in our MCP server right here on ChatGPT. Now, if I come back here and now I click the X or the little plus button, under more, I can see my MCP server. And when I have it on there, that's OpenAI's way of telling you that they are injecting all of those tool calls into the system message. So now I can ask something like, hey, take a look at my X timeline and tell me what is the most popular topic today based on how many people are talking about it. And this will start to make calls directly to the X API on my server that's running over in Cloudflare, which is hosting all of my auth tokens and everything to be able to go and actually access it. And here you can see we called a tool. And if you open this up, you can actually see what tool gets called. It's pretty neat. X New AI's Encyclopedia Galactica project. Okay, interesting. So, all right, this is probably using their like little, get timeline. So I got 100 results out of my timeline, and it said that that was one of the more interesting things today. I don't know if that's true, but whatever. Hey, who are some of my followers? Give me the coolest name of one in the top, I don't know, 30 results. Let's see what it does here. Calling my tool again. So you can imagine exposing one of these MCP servers for yourself, for your own tool. So it didn't accept self as an ID. Amazing. No, just get some of my followers, silly, and tell me what name stands out. At the end of the day, you're at the mercy of these AIs to come up with a good decision. Here we go. One name jumps off the page, Xaviera Electric. Okay, so obviously you can see I could implement all the right tools and everything like that. and then just be like, hey, post a tweet for me, or whenever somebody follows me, do this action via a webhook or something like that. You get the idea. All right, let's jump back over here. And run through real quick. These are my rules for using MCP. Number one, always write your own server. I know this sounds silly. Obviously, there's exceptions. But in general, these things are so risky. I would highly recommend you write your own MCP servers that you and your organization can trust. They're not that hard to write, and you can expose exactly what information you want. Number two, all servers that you write should be stateless. This is my opinion. You're going to save yourself so much headache and be able to deploy your servers wherever you want if they're stateless. Number three, all servers should use HTTP transport. That's the most common transport. If you want to connect it to, OpenAI or something like that, you can't even do it if it's not an HTTP transport. I get why the other ones exist. I'm just telling you, pick this one from the beginning. Number four, all servers should only use tools. I just wouldn't mess with any of that other stuff. Tools are capable of doing anything else. Let me give you an example. Let's say you want to provide a prompt. Well, the AI still has to pick that prompt. Why not just pick the tool that gives it the same context? MCP and tools actually work pretty good with RAG just as tools. No need for any of the other stuff. And those are my rules. I would be remiss if I did not tell you about this ridiculous deal. I know Daniel already did, but I'm telling you as well. There is a Black Friday day, sale going on, 45% off for the AIDD masterclass. This is like irresponsibly cheap. Please go grab it if you work on AI. We talk about all kinds of AI stuff in there, including MCP servers, but lots of other stuff about what are some best practices for using AI. What kind of workflows can we have and exist? How do you choose the right editor, not just today, but when new ones come out? New one came out yesterday, by the way. Things like that. And that's it for me. These are my things. Go to AIDD.com. Follow me on the X. Yeah, I suppose you could even try using that MCP server. Hey, it's deployed. It's out in the world, so you can try it. And that's it for me. Thanks.
Hey, Justin. Excellent talk, sir. Really appreciate it.
Thanks, man.
So I do have a few questions for you. Let me change our view real quick so we're kind of side by side here. That looks a little nicer. And then I'm going to start grabbing some questions from the chat. So we have. By the way, you ready for questions? Am I just jumping in here? You good to go?
Oh, I'm good to go. Give me the questions.
Excellent. All right. So the first question is, are there any other techniques that you think will one day replace MCPs?
This is a good question because it's not really a technical one, right? It's like a market one. And there's the first mover advantage of MCP is so big, and the amount of effort that's gone into the integration is so big that I don't really think it's going to go anywhere. I do think the MCP spec will evolve dramatically over time as more I don't want to insult anybody. I think it'll evolve over time. And I think what you'll probably see is sub protocols emerge. So like I even tweeted today about this. I think there should be like a simple simple MCP, SMCP or something like that, which is a subset of the things that are in MCP. So like it's only tools and it's only these other things. And by doing that, we can achieve some of the goals, which I agree with on MCP, like making the servers ridiculously easy to build. So I would like to see things like that, along with a few more intelligent decision-making pieces, like how do you do progressive discovery so they don't all the tools end up in your list. It's like almost a non-starter for using very many of these things. You need to turn them on and off constantly.
Yeah, definitely. Very interesting. All right. So our next question is, does the agent, kind of just answered this one, but does the agent include all the available MCP functions each time? What if you have 100 of them?
Each time.
Yeah.
Every single request has all of them, even if they're completely unrelated to what you want to do. They're all there. The only little tiny caveat is in your MCP client, most MCP clients, not all of them, but most MCP clients offer a way to enable or disable individual tools. This is where the spec, though, is sort of broken, because if you enable and disable individual ones, the whole point, if you remember, is that the tools are supposed to be composable, right? Like I'm like on my X one, I need to have the ability to get users and then go load more information about a particular user. If I start disabling tools out of there, then you have now departed from the original author's design for how to use that MCP tool. So you're going to run into places where it's like, oh, you didn't give me the ability to go get anything, because you turned that tool off or something. So nobody does. The reality is, like, nobody turns these tools off. And if you don't turn them off one by one, they all go.
Yeah, I definitely found myself in Cursor. Like you can see it, it's there, right? But it's like with Playwright's tools, am I really going to look through all those and turn just the ones I don't want off?
Exactly.
Yeah, that's it. So am I right in hearing that this is your main qualm, your main issue with MCP, right?
It's this and the multiple transport and the statefulness and the fact that there's actually no, there's a lot of qualms, and the fact that there's too many capabilities in the spec. So nobody's implementing the spec. We're all implementing like the little pieces of the spec that we like. It's
Sure.
cool that the spec allows for that to exist. Like, it is possible to have the spec, to have a client and a server that don't agree on everything still talk to each other. That is very cool. And maybe it was needed for this early days stage. But I think it's pretty clear that the only thing people really want out of this is tools.
Cool. All right. Thank you, Justin. Let me get one more question for you here. Let's go for, is the server that you wrote public on GitHub?
Server's not public on GitHub, but I suppose that URL is public. Cloudflare-mcp.formkit.workers.dev. If you go there, you could install that on your own ChatGPT and burn up my free tokens.
Nice. All right. That is it for our time. Thank you so very much for being here with us, Justin, and sharing your expertise.
All right. Thank you so much.
Awesome. I'll see you.